Oh hey! Good day everyone! Especially to you sir, I am Jarek Sigalbo and for today's video, I am going to discuss the nature of electromagnetic wave and the concept behind the Doppler's effect. Yes, you heard it right. We will be discussing today the nature behind the electromagnetic wave, how do waves are arranged in an electromagnetic spectrum, and how do waves are produced. And also, for today's video, we will be discussing the explanation and the concept behind the Doppler's effect. Okay, let's get started. What is the nature of electromagnetic wave? How do waves are produced? And how do waves are arranged in an electromagnetic spectrum? What is electromagnetic wave? Okay, maybe some of you are asking right now these questions, but please allow me to answer this.
Okay, what is electromagnetic wave? Electromagnetic waves are synchronized oscillations or the movement back and forth at a regular speed of electric and magnetic fields that propagate at the speed of light through a vacuum. The oscillations of the two fields are perpendicular to the direction of energy and wave propagation, forming a transverse wave.
And now, to answer the question on how do electromagnetic waves are produced, electromagnetic waves are the combination of electric and magnetic field waves produced by moving charges, meaning to say, the creation of all electromagnetic waves begins with a charged particle. This charged particle creates an electric field which can exert a force on other nearby charged particles. When it accelerates as a part of an oscillating motion, the charged particle creates ripples or oscillations, meaning to say the movement in which back and forth at a regular speed in its electric field and also produces a magnetic field. Once in motion, the electric and magnetic fields created by a charged particle, always note that magnetic fields and electric fields are created by a charged particle, are self-perpetuation, which means the time-dependent charges in one field. It's either the electric again and the magnetic field to produce the other. Both electric fields and magnetic fields in an electromagnetic wave will fluctuate in time, one causing the other to change. Always take note that the electric and magnetic fields are created by a charged particle, meaning to say do not exist without the presence of charged particle, and it is considered as self-perpetuation, which means time-dependent changes in one field to produce the other field.
Electromagnetic waves, otherwise known as photons, are produced anytime as charged particles experience a change in velocity. The electromagnetic wave, otherwise also known as radiation, that is produced when the charged particle changes its velocity is how energy is conserved. This energy is what we call light.
To answer on how do electromagnetic waves are arranged in an electromagnetic spectrum, allow me to answer this one. In order from highest to lowest energy, the sections of the electromagnetic spectrum or components of electromagnetic spectrum are named or arranged from lowest to highest energy, meaning to say it has the first one has the highest wavelength, but consequently has the lowest frequency, and it is the radio wave. We have microwave, infrared, visible light, which is only the visible among all the electromagnetic wave components, ultraviolet rays, X-rays, and gamma rays. Gamma rays here has the lowest wavelength, but always take note that has the highest frequency. Again, the basis on how do waves are arranged in an electromagnetic spectrum are arranged or are based on the lowest to highest energy. The first one has the highest wavelength and lowest frequency, which is the radio wave, and the lowest frequency and lowest wavelength rather, and has the highest frequency is at the last part of the electromagnetic spectrum, which is the gamma rays. Always remember, wavelength is inversely proportional to the frequency. The higher the wavelength, the lower the frequency. The higher the frequency, the lower the wavelength. That is how two electromagnetic waves are arranged in an electromagnetic spectrum. And in terms of its properties, electromagnetic waves are members of a family of waves with common properties called the electromagnetic spectrum. All electromagnetic waves, always remember, are transverse waves, can travel through a vacuum, can travel at exactly the same speed in a vacuum, the speed of light, which has 300 million meters per second. Like all waves, electromagnetic waves transfer energy from one place to another, can be reflected, and can be refracted. And that's a wrap. I guess that would be all for the nature of electromagnetic wave. How do electromagnetic waves are produced, and how do electromagnetic waves are arranged in an electromagnetic spectrum. And now let us move on to the next topic. We have the Doppler effect. And yes, I know what you're thinking right now. Maybe some of you are asking, what is Doppler effect? Who was the first proponent of Doppler effect? What is the concept and explanation behind the Doppler effect? Well, allow me again to answer these questions.
Okay, Christian Johann Doppler was the first one to propose the Doppler effect. Doppler effect or Doppler shift is a phenomenon that is observed whenever the source of waves is moving with respect to an observer. For example, an ambulance crossing you with its siren blaring is a common physical demonstration of the Doppler effect.
Doppler effect is an important phenomenon in various scientific disciplines, including planetary science. The Doppler effect describes the changes in the frequency of any sound or light produced by a moving source with respect to an observer. In physics, Doppler effect is defined as the increase or decrease in the frequency of sound, light, or other waves when the source and observer move towards each other. Waves emitted by a source traveling towards an observer get compressed, while in contrast, waves emitted by a source traveling away from an observer get stretched out.
Here is the perfect demonstration of the Doppler effect, both from the observer letter A and observer letter B. And the next example is with this one. If the observer is near the object, then the frequency or the pitch of the sound is high and the wavelength is low. However, if the stationary observer is away from the object, then the frequency is low while the wavelength is high.
Doppler effect is the apparent change in the frequency of waves due to the relative motion between the source of the sound and the observer. We can deduce the apparent frequency in Doppler effect using the following equations.
These are the formulas you can utilize in answering the different problems and equations with regards to Doppler's effect.
And I guess that would be all for the Doppler's effect. Once again, I am Jerry Sigalbo. Thank you for watching. I hope you learned something from this video.